Welcome to Chem Talk, Breaking Down the Basics series.
Hello everybody, my name is Julian, and today we'll be doing part 2 on the videos about quantum numbers. Now we're going to go over applying quantum numbers. So you can see the periodic table here, and before we do anything, I want to go over how quantum numbers are actually sorted in the periodic table. As you know, the periodic table has different columns and different rows. These columns we call groups, and the rows we call periods. Now, these different rows are actually sorted by energy level. So hydrogen and helium have all of their electrons are energy level 1. Now lithium through neon, they have electrons that are either energy level 1 or 2. Sodium has electrons of energy level 1, 2, and 3. Potassium, 1, 2, 3, 4. You get the idea. Wanted to go over that real quick with you. And now we're going to go over an example. This right here is sulfur. 16 protons, 16 electrons. I've just put out the neutrons for now just for simplicity. Now, this has many different quantum numbers. So first, I'm just going to pick a random electron, and we are going to arbitrarily decide some quantum numbers, and then I'll go over listing all the quantum numbers. So this electron right here is an energy level 1, 2. So we know it's that. We know its angular momentum could be any value from 0 to n minus 1. Since n is 2, that means 0 to 1. So 0 or 1. In this case, I'm just going to choose 1. So that's its angular momentum. Now for its magnetic quantum number, it could be any value from negative L to positive L, which in this case is negative 1, 0, 1, right? I'm going to choose, I don't know, 0. And then for magnetic spin, it can either be positive half or negative half. Let's just assume it's negative half, which represents our downspin. So if I had an N of 2, an L of 1, an ML of 0, and an MS of negative half, these would all be valid quantum numbers for an electron right here. Now, let's determine what are all the possible quantum numbers for sulfur. I'm going to erase all this and give us some more space. First, let's start with the N. How many energy levels do we have? Well, this is in row 3 of the periodic table. And I listed it out here. 1, 2, 3 different energy levels, 3 different distances from the nucleus, which means our N can either be 1, 2, or 3. Now L, our angular momentum, will always start at 0. And then it ends at n minus 1. So 3 minus 1 is 2. So 0, 1, 2. Pretty straightforward. Now, all of our possible magnetic quantum numbers are negative L to positive L. Since our biggest L is 2, that means all of our possible numbers could be negative 2, negative 1, 0, 1, 2. And then finally, our electron spin quantum number will always be the same, no matter what. It can either be negative half or positive half. These 3 all key off each other. This one will always just be these 2 options. This would be a valid answer for answering all the possible quantum numbers of sulfur. You can go with different examples. So a bigger one would have larger quantum numbers. The biggest thing to remember is the larger the energy level, the larger your angular momentum, the larger your magnetic number. Yeah. So if you are ever asked this question, just remember N for energy levels, L 0 to n minus 1, ML negative L to L. Thank you so much for watching, and I hope you all have a good day.
That's a wrap for today's episode of Chem Talk, Breaking Down the Basics series. Thanks for watching. If you enjoyed this video, don't forget to hit that subscribe button. Until next time, keep learning, stay curious, and we'll see you in the next Chem Talk, Breaking Down the Basics episode.